What's up guys, it's Novice and I'm back with another video. Today's topic will be on regular expressions. So first I'm going to describe what regular expressions are. So regular expressions are used to find patterns or search for different types of string within a file or some sort of output. The way that I like to think about regular expressions or regex, as the cool kids call it, I think of them as an advanced search that people could do on like Google, because as you know with Google, you type in a specific phrase and then it pops up and populates with the information that you're looking for. However, there's much more on Google than what you just searched for. So that is how I kind of try to visualize how regular expressions work to find you information. Regex or regular expressions can be used for multiple things, but one thing that they're used for a lot is to look through things like logs or things that are containing information that makes it easier to search through and filter that information, making it more appealing for your eyes and making it less congested so you can see what you're actually looking for. Now, the reason I'm making a video about this is I had to learn how to use regex or regular expressions on Python for a specific project that I had in mind. Now, I had to do this because when I dive into a project, I like to learn the nitty-gritty of everything. So once I saw this, I found it very interesting and realized, oh, I could use this a lot in the future as well. So might as well learn and make a video on this too. Now, the way that we're going to be using regular expressions are going to be with Python. Now, Python has its own module for regular expressions called RE. And to start it off, you would pretty much just have to import that module into your Python instance, and from there you'll be able to use it. And if you want, you can pull it up on whatever editor that you're going to be using and follow along with me as I go through some of the things that this module can do for you in Python. Alright guys, now we're going to hop in and go through a little walkthrough of some of the things that regex can do. I hope you guys find this entertaining and enjoy it. Now, without further ado, let's hop right into it. Alright, and here in this Python file, we can see everything that I've done prior. Now, in all honesty, this is a re-recording because it's my first recording. I didn't show you guys any of this except for a few at the end. So starting off, we'll start with import re. This imports the regex module that I've been telling you guys about. And then here we have a variable that I listed called file. Now what file is meant to do is have a whole bunch of letters, numbers, special characters, common patterns that you might see everywhere, so that we can use it in our examples to try to pull them out. And then that goes all the way until down here. And then we have a variable called p, in which we run re.compile. Now what re.compile is meant to do is that it's meant to identify patterns within whatever it is that you give it, in a sense. It's meant to identify specific patterns that you specify. We'll go into that a little bit later. And then finally, we made another variable called found, in which we get every iteration of this pattern that was found in whatever variable, whatever location that we put here. In this case, I put file so that we can find that. And then finally, found x in found print x. So this pretty much goes through the found variable, and then prints out all the iterations of the pattern that was put in the re.compile. Now I said I'd come back and describe what this R meant, and simply this is how we are able to interpret whatever we put into the regex, because for this re module there are a whole bunch of special characters that are used, and without using that R, it could easily confuse it for an actual character, even though that might not be our case. For example, let's start off with our first special character, which is simply the dot. Now, what the dot is meant to do is it is meant to represent any character except line terminators. So if I were to run this right now, it would get all of these individual characters except for the new line, any spaces that I have in between, or any return functions. So I'll go ahead and run that right now so you guys can take a look. I was incorrect, not the spaces, but any return characters or line terminators. So anywhere that a new line is made and or a return function is called. So, or not return function, but a return is called. Now, here we can see all of our characters ranging from letters to numbers to capital letters to lowercase numbers to capital letters to lowercase letters, all the numbers, and then special characters as well. Now, moving onwards, our next set of special characters will simply be, is it \D? Now, what this is meant to do is that it is meant to pull any digit from whatever source it's pulling from. In this case, since it's pulling from file, it'll go through and collect all of these numbers without the hyphens in between them, and then it will display all of them. So let's go ahead and run that, and boom, as I said, that's exactly what it did. Now, the next thing, and something else you'll notice with the read special characters, is that if you use the uppercase of that same letter, it means the exact opposite. So the lowercase d was looking for all digits within the file variable. Now what the capital D does is that it looks for all the non-digits within the file variable. So let's go ahead and save this and run this. Now we're gonna get the exact opposite of what we got prior. We got everything that is not a digit. That includes new line, characters, special characters, alphabets, and no digits. Now the next one that I want to show you is the way to get words or alphabets in this case, which is the lowercase w. Now if we save this and then run it, you'll be able to see that all we get back are letters. Oh, I'm so sorry. We get back letters. I believe it's alphanumeric characters plus the underscore. So I was mistaken about that one. Yep. Trying to see if it got an underscore just to show you guys. Here we go. Then moving forward, if we do a capital W, it gets the reverse of that. So it gets any non-alphanumeric character or any special character that's not an underscore. So here we just see spaces, commas, periods, and new lines, as well as @ symbols. Everything that wasn't here prior. All right. Sorry about that. The next special character that we have is the \S. Now this looks for any white space that is available within your variable or your file or whatever it is that you're searching through. So let's go ahead and save this, and all we should get are spaces, I believe new line characters as well. Yep, just spaces and new line characters. And then as said previously, if we capitalize that S, so call it big S, and we look for that instead, we're pretty much just gonna get everything that's a non-space character. As you see here, numbers, special characters, everything that is not a space or a new line character. Now, the next one is something I find really interesting, and it's this -B. Now this is interesting because it is one that cannot be ran by itself. It takes its -B and then whatever character or word is right next to it. Excuse me. So, what this looks for is it looks for if there are any spaces or line terminators, in this case new lines, next to a specific word. For example, I will use the word my. So, lowercase my. Now, when I save this and then search for it, I come up with 3 matches. Now, this is looking for those words that have a space to the right or a new line character to the right of it, or to the left. Sorry guys, I'm not good at directions. To the left. So here we see this my. Here we see this my because right before it is a new line character. And then finally we see this my up here. Now, the next one I do would be a capital B. Now, this will look for the word my, but the criteria is that it should not have a space or a new line character before it. Now, just looking through this, I made one up here, and it is this my right here next to these 3 M's. This should be the only one that pops up after I run this, unless I put what's on. Nope. Okay, so running it now, and it is referring to this my because this my does not have any spaces behind it, nor does it have any new lines before it. So that is what the B and capital B special characters do. I just found it the most interesting. All right, and now next for the special characters, we're done with the backslashes for now. Now what we're gonna dive into is something called a character set, and it's represented by brackets. Now a character set represents, I guess, the choices, a choice of what to look for within the specific variable, file, or whatever location I'm looking at. So for example, if I did within this character set, within the brackets, A through Z. Now these are capital A through Z. And I save it and I go ahead and run it. It should only get me capital letters back from this file variable. And it goes ahead and does that, starting from all the alphabets that I listed here, and then it goes through and gets all the other capital letters, which are I, and this capital M. Now, this can work to support a lot of different things. So even after that, capital A to capital Z, we can do lowercase a to lowercase z, and it will look for both uppercase and lowercase letters. Not only that, you can even throw in a space if you want to. Run it, it gets the space. You can throw in a hyphen if you want to. Run it, it goes through and gets a hyphen. And this is how a character set can be used. It can pretty much be used to specify what you're looking for. Whether it could be words, we could even change this up so that it can be numbered, only digits. Run that, and here we only see digits that pop up in here. Now, something else I want to mention about character sets is this special caret right here. Where did that caret? Here we go. All right, so using this negates whatever is in the character set. So say I am looking for everything else except capital letters. If I do something like this and then run it, I will be returned with everything that is not capital A, capital B, all the way until capital Z. Now that is how a character set works, and it can be useful and used in many cases, but that is the basics of a character set. Now moving forward, we're going to speak about groups. Now groups are going to be represented by parentheses as opposed to brackets for character sets. Now a group is pretty similar to a character set, except it gives specific options and specific patterns that should be looked for. For example, within a character set, if I did something like M and Y and then ran it, it's gonna look for all capital M's and all the Y's that are in here. However, with a group, it presents
an option. So I can just look for my, run that, and it will only look for the capital Mi's. Now, why this is important is because you can use it to look for multiple things within the group. So let me see what else is in here. So Gmail. Oh, whoops. Alright, run it. Now through this we're able to get those specific words and those specific words alone. Now a group pretty much gives you the choices of what to look for, and then it goes through and grabs all of those things. So as we put here, we put my, mouth, and Gmail. And because it was all within a group, we were able to retrieve every single one of them. And that's pretty much how a group works. And now, another special character that I want to show you is the character, not the character, the caret itself outside of a character set. So using the caret followed by something else is meant to grab that if it is at the very beginning of the string. Now, in this case, we'll start with P. P is not at the beginning of the string. Wait, let me do U so I can explain something a little better. Now, U is not at the beginning of the string, however, it's right here. Now, when you think of the string is this entire character all the way up until this, not entire character, this entire string all the way up until Y. So if I run this, it gives me nothing. The only way that I'll be able to retrieve something is if it's I, because I is at the very, very beginning of all of this. So if I press this and it runs, I'm matched with I because it's at the very beginning of the character, or not the character set, of the string. Now, after that, there's something that shows you how to grab stuff at the end of the string, which is this $sign right here. Now, as opposed to the caret, which was at the beginning, because this is locating something at the end, it must also be put at the end. So let's see, the number 5 is put at the end of this line here. If we search for it, it does not go through because we're looking for 5 at the end of the string in its entirety. So if we switch this with a Y, which is the very last thing here, and we press play, it matches.
But now we're going to hop into another interesting section known as quantifiers. Now, quantifiers are used to help determine the amount of times that a certain character should appear. I don't think I'm explaining that very well, so I will demonstrate. For example, let's say I'm trying to find a phone number. I have the option to do something like this in this file because I know the pattern. It's a digit, a digit, a digit, followed by a dash, followed by a digit, and another digit, another dash, and then finally followed by a digit, a digit, a digit, and a digit. So if I run this, I should get all 3 phone numbers, and I do. However, there's an easier way that we can do this, and that's by using quantifiers. Now, there are 4 or 5 quantifiers that I'll talk about. Let me see. So let's remove this. Now, the first quantifier is known as an optional quantifier. Now, quantifiers are used after a specific word, a specific character is specified. For example, here we're specifying that we want to find a digit. Now, I am going to show the optional quantifier by using this. Now, this just states that the digit is optional here. Actually, it would be smarter to show you here. Now we have social security numbers or examples of social security numbers in here as well. So what we'll do is we'll make the third digit in the second set of 3 optional. Why are we doing this, you might ask? This is to show that once an optional operator is put into play, it means that it will locate any strings in the file that have this character or don't have this character, but this character alone. Let me run it so I can see if I can explain that better. So here we are displayed with phone numbers, and then underneath that we see the social security numbers. Now, why are we seeing the social security numbers? Well, for the 6th digit number, we put the optional quantifier, which made it optional for us to have that sixth digit. Instead, we could have 5 or we could have 6, and either way we would still get to see the results of that. That's why we're able to see both phone numbers and social security numbers in this case. Now the next quantifier we have would be the 0, or is it 1 or more quantifier? I believe it's 1 or more. So here we'll display the 0 or more quantifier, which is used with the star. So let's see, another way to show this would kind of be with the optional one. So in this case, we put this star next to the 6th digit character. Now what this does is that in that 6th position, it looks for either 0 digits that are between 0 and 9 or more. And if it's able to find those, it will display it. With that being the case, it should still print out the numbers, the phone numbers and the social security numbers again. So let's go ahead and save this and run it again, and we get the same result. Now the next quantifier, which is this plus sign right here, stands for 1 or more. Now with the 1 or more, it's kind of as it states. Since the quantifier is next to this 6th digit, there has to be at least 1 digit in that 6th place for it to be found. That means we're no longer going to find the social security numbers, because in that 6th place there is no digit, there is a dash. However, in the phone numbers there will be a digit. So let me go ahead and run it now, and we can only see phone numbers are displayed. Now that is how quantifiers work, and the final way of quantification that I want to show is using curly brackets. So with curly brackets, you can make it really clean if you know and understand how they work. So as stated before, if we print this, you can find all the phone numbers. That's nice. Now with the curly braces, you can do this in a much easier fashion. Now with the curly braces, with the dash D, we're going to look for 3 of the digits before this dash, and I will continue to do the same here, making it like this, and then finally here we'll increase it to 4 because we expect 4 digits at the end of a phone number. Now once we do this, it will still give us the same results, but we had to type a lot less, and it should just be easier on the eyes for people who are looking through. Let's save this. Boom. It shows the exact same thing using the exact same strategy. Now we can also use curly braces in a way where we have 2 numbers. In this case, I'll use the numbers 2 and 3. Now the 2 in this case is the minimum amount of digits that can be between these two dashes, and the 3 is the maximum amount. Now what this is going to do is that it will make it possible for us to also search for the social security numbers, as there are only 2 between the two dashes. Now let's run this and we should get a better idea of what I'm talking about. Boom. Now because the minimum is 2 digits, we see that when there are 2 digits here, we get this. And because the maximum is 3, we are still able to see the phone numbers, the 3 digits in the phone numbers. Now that is what I wanted to show you with special characters, and not special characters, quantifiers. Now that's all that I had to say as it regards to using regular expressions with Python. But now I also just wanted to play around with it and show you guys what you can do with it. So right here, the challenge I'm going to do is to try to find all four of these email addresses by creating a specific pattern to do so. So first we'll try to match it with the first one. So here we see that we're using strings or alphanumeric characters in the beginning of our email address. So we'll use \W. Then we'll physically put in the @ symbol. We also see that we're using Gmail. Now I will also use \W to capture any alphanumeric characters. Then I'll use dot, and then I will do comma, and then I will play it, and it returned me nothing. Let me see. Oh, now I forgot to put the quantifiers here. I'm sorry. So in front of the W, I'll put plus, indicating I want one or more alphanumeric characters, and I'll do the same for the \W after the @ symbol. Now, even in that, we're able to get 3 email addresses. However, there's one email address that we weren't able to get, and that is the US government at unitedstates.gov. Now in this case, that's simply because we use the .gov at the end. But because we know now about how to use groups, what we can do is set a group that looks for .com or .gov. Now in this case, when I save it and I look, we're able to find that 4th email address too. Now I brought this up because, as I said, in one of my projects, I pretty much had to learn how to use regular expressions, and I really believe that it could be helpful in so many other things. Now hopefully I was able to explain this well. If not, let me know in the comments. Try not to be say whatever you want. Say it in a way that I can understand it, so that I can continue to improve these videos for you. But I hope that you guys were able to take away how important regular expressions are, how they can help. For me, I can see them being very beneficial in looking through log files, looking for information. Specifically, I kind of showed how you could create something to look for social security numbers, phone numbers. As an ethical hacker, that can most definitely be useful when you're looking for when you're doing reconnaissance and things of that nature, to find different types of information on different types of people. Now with that being said, that's pretty much all I had for this video. Just wanted to go through regular expressions because I found it really cool and really helpful. Now if you guys like the video, please go ahead and like the video. If you want, go ahead and subscribe, go ahead and try to support me, and comment something down below. Something funny, something goofy, something mean, something sad, something happy. Just interact with the video. Make me know that you guys are actually a little interested. Now with all of that being said, I'm pretty much done.